Hey everyone, welcome back with Mrs. Struble. In this video, we're going to talk about exponents. We're going to learn how to use exponents to write and evaluate expressions, and also how to write products using those exponents. So let's go ahead and get started. Starting off with the basics of exponents, a couple things we need to know. First of all, this is an exponent. The bigger value that it's attached with or next to generally is what we identify as our base. Together, these two combined is our power. Our is a product of our bases, okay? And the exponent tells us how many bases are being multiplied together. Okay? In addition to that, we also need to understand the different types of formats that involve exponents. We have what's called the exponential form, expanded form, and standard form. And very uniquely named, the exponential form is that form in which we use that exponent. Okay, so for example, if I have 1/2 to the 5th power, writing it using that exponent of 5 is in exponential form. If I were to expand it out, again, the exponent tells us how many, so there are 5 values that are inside the parentheses here, which is 1/2. So to write it in expanded form, I would write 1/2, 1, 2, 3, 4, 5 times. Okay. Our standard form is just our evaluated value. Okay, so that's the basic number that we're dealing with. So if we were to multiply all of these 1/2s together, and well, when we multiply fractions, we multiply straight across. So 2 times 2 times 2, that's 8, times 2 is 16, times 2 is 32 if you're following me. And we get a standard form of 1/32. Okay. Lastly, to cover our bases here, our basics, we need to understand how to use exponents with negative values. Here's the tip I always like to share. Exponents take or are talking to the character immediately before them. That's to their left, not their right. Directions. Okay, so in this example, when we have -3 to the 4th and then also -3 to the 4th, what is really going on here with this exponent? Okay, so this exponent of 4 is talking to, if you will, the parentheses. Okay, so everything inside those parentheses is being repeated 4 times. And inside those parentheses is in fact -3. So we have 4 -3s, or 4 sets of parentheses, all being multiplied together. Whereas over here, on the other side, this exponent is solely talking to that 3. Now, if you remember, any multiplication problem has a factor of 1. We just don't normally write it unless we need it. Okay? Here is more or less saying we have -1 times 4 3s all being multiplied by each other. So why does it matter? What's the real big deal here? When you do the multiplication of this, you will find that to the left-hand side here, we have the answer of 81. However, over here on the right-hand side, we have -81. They're total opposites. So yes, understanding what that exponent is referring to or more or less talking to is very important. Let's go into some examples. Writing expressions using exponents. So in this first example, we have -7 repeating. It repeats 1, 2, 3 times. So that tells us that our exponent is going to be 3. we have to ask ourselves what is repeating. If I were to write it like this, it is incomplete because this tells us that the 7 is repeating. However, it's not just the 7 involved, it's also the negative. So we need those parentheses to stay intact. So we have -7 in parentheses to the 3rd power. Down below at the second example, pi times r times r times r. Again, we're just looking at what's being repeated and how many times. Here are 2 pi's all being multiplied together. So we could say pi squared or pi to the 2nd power. Next door, we have 3 r's, once again being multiplied together, so it's r to the 3rd power. We don't know what r is yet. We know what pi is, but we're just going to leave it in exponential form. Pi squared times r to the 3rd power. A couple more with these exponents. Let's practice evaluating these simple expressions involving exponents. So once again, those parentheses, they matter. This 4, this exponent of 4 is referring to the parentheses. It takes the character immediately before it. So it's the parentheses. Everything inside the parentheses is repeating 4 times. These parentheses are 4 times. So even if you have to put the 4 sets of parentheses first before you keep going, do it. So we have that -2 inside those parentheses. Each set of those parentheses. -2 times -2, well, that's +4. And then we have 4 times -2 is -8. And -8 times -2, that's +16. In the next one, that exponent is with that 2. Okay, the 2 only. So this is referring to the fact that there are 4 2's. So we're going to go ahead and write 4 2's out. And then, hey, there's a negative in front. Now you don't have to write that -1. It's going to go away when we're done multiplying all of these factors anyway. But if you'd like to make more sense of it, yeah, you could say it's -1 times 2 to the 4th. Sure. Okay. All right. So once again, we have 2 times 2 is 4, times 2 is 8, and 8 times 2 is 16. But we also have that -1. So this becomes -16. Moving on. Let's see how these work in more complex expressions. So when we'll have to use the order of operations. So just a quick review of those order of operations. The well-known phrase is PEMDAS, or please excuse my dear Aunt Sally. The P stands for any sort of parentheses or grouping symbol is what we call them. Okay, so it could be brackets, it could be braces. Oops, that's a very bad example. Okay, or literal parentheses, it's fine. Dear heavens. It's not working right. There, okay. So any grouping symbol, we're going to dive into that first and foremost before we hit anything else. And then once we have done that, we're dealing with those exponents next. Multiplication and division from left to right. So we're doing those at the same time from left to right, like we're reading this problem. And then same thing with addition and subtraction. From left to right, we're solving all the addition and subtraction from left to right, like we're reading a book. Okay. All right, let's take a look at A. I don't see any grouping symbols or parentheses, but we do see an exponent right here. So we're going to take care of that exponent first. And it is referring to that 3. So there are 4 3's all being multiplied together, like so. And once we do that, we get 81. We didn't use anything else in this expression, so let's just drop it on down. Okay. And then we keep going with PEMDAS. Well, again, parentheses are out of there. Exponents are now gone. So now we're going to do multiplication and division. I do see one multiplication here, the 2 times 81. So we're going to go ahead and take care of that quick. And 2 times 81, that's 162. Again, drop everything else down that we did not use. And go ahead and add on through because that's all that's left. 165 for that first one. Let's go ahead and do that second one. If I have to, I'll use my little checklist up here for PEMDAS. I once again don't have any grouping symbols, so I'm going to take care of those exponents first. One at a time, I'm going to take care of them. So 3 times 3 to the third power is the same thing as 3 times 3 times 3. That's equal to 27. And then 8 squared, that's the same thing as 8 times 8. Well, that's equal to 64. Refrain from trying to multiply them. That's the most common mistake, is people wanting to tell me that 8 squared is equal to 16. No. Okay, that means there are 2 8s being multiplied together. Okay? All right, so if you have to expand it if you have to write it in that expanded form, do it. Okay? All right, everything that we haven't used, we're going to drop on down. So that subtraction sign in between those guys, we didn't do anything with him. We kind of ignored it. Okay? Nobody likes being ignored, so let's drop him down. Now we're done with those exponents, multiplication and division from left to right. We've got this 64 divided by 2 and 64 divided by 2. That's going to give us 32. Drop everything else down. And then we end up with 27 minus 32. Yes, it's going to be a negative. That is okay. It happens. It's negative 5. Okay. Yay! Last one here with order of operations. All right. Here. Again, order of operations, we've got that PEMDAS algorithm helping us out. So taking a look at that grouping symbol, the parentheses, we're going to look inside the parentheses to figure out what we do first. Okay, so inside this parentheses, I see negative 10 squared plus 70. I want to follow the order of operations inside parentheses too. Okay, so inside this parentheses, I do not have any other grouping symbols, so parentheses are done inside there. Instead, we're going to do the exponent. So the exponent will come first. We're going to take the 2. Now, what is the 2 talking to? What is the 2 referring? It's referring to the 10. Okay, not the negative, but just the 10. So we're talking about 2 10s being multiplied together. Well, 10 times 10 is 100. And then let's drop everything else down. Well, what didn't we touch? We didn't touch this negative. We still have the plus 70, and yes, it's still in parentheses. We just took care of that exponent, not the entire parentheses just yet. Okay, still working inside that parentheses because, hey, we technically really hasn't finished that first step of parentheses. Okay, in order to finish parentheses, we have to have one value inside those parentheses. We don't have that yet. So we have to do that last step and take negative 100 plus 70. And we get negative 30. Now we have completed with those parentheses. We do not need those parentheses any longer. We just have one value. So bring everything else from that original top problem down. And now we only have one operation left, that multiplication. So it's negative 3 times negative 30. We get positive 90. Remember, this is why I've taped this, guys. If I'm going too fast at any point in time, you can slow me down, you can pause, do what you need to do, okay? Let's practice a situation that involves a real life scenario. So I'm working at a technology company, and the annual profit in the thousands of dollars here earned by this company after so many years after opening is represented by the equation P is equal to 1/10 x cubed plus 3. If that's the case, my question is, how much more profit did this technology company earn in the 5th year than it did in the 4th year? In order to first answer this question, we need a couple of values. We need to identify, well, okay, how much did they earn in year 5 or their 5th year? How much did this company earn in their 4th year? And then to figure out how much more, we're just going to simply subtract those two numbers. So let's dive in. It's a simple substitution. We've got the profit is equal to 1/10 x. Well, x is our years, remember? So let's do the 5 years first. Sure, why not? Cubed plus 3. Okay. Solving this expression, 5 to the 3rd power comes first. That's 125. 125 times 1/5. And remember, yes, it's talking to the 5 only. Okay. Bring everything else down. We're going to do that multiplication. And we get 12.5 plus 3. Okay, 15.5. And remember, this is in the thousands of dollars. So on that 5th year, this small company made $15.5 thousand. So $15,500 essentially. All right, so that was year 5. Let's check out what happened in year 4. Okay, change the color a little bit here. So now our x is going to be 4. Why did I put parentheses? I put parentheses because I do not want to confuse the fact of what the exponent belongs to. Okay? The exponent goes with the x. So no matter what x is, x could have been a negative, depending on the situation. Okay? I use the parentheses to make sure that whatever x is, that's the number that's being cubed. So I recommend if you're ever substituting in for a value that has an exponent, use those parentheses. You'll never go wrong. All right, let's keep going here. Take care of this exponent first. 4 to the 3rd power, because that's what's inside those parentheses. That's what that little 3 is talking to. Okay, that's equal to 64. Copy everything else down. 0.01 times 64 plus 3. 0.01 times 64, that's 6.4 plus 3. And we got a total of 9.4. Okay. Now all that's left is to find the difference. And 15.5 minus 9.4. How much more did this company make? They made a total of 6.1 K more. So $6,100 more, if you want to put it into that form. All right, phew. We've covered a lot, most of it pretty basic. You should have already gotten a lot of this in previous lessons. So let's go ahead and give you some of these to try on your own. I want you to go ahead and write these down, pause the video, and give them a shot. Now that you've paused the video, let's go over them quick. Writing those products using those exponents, you should have had yes in parentheses here. You have to have a fraction in parentheses, okay? Because it's talking to both the numerator and denominator. Without it, I don't know if you're talking to just the numerator or not, okay? It looks like it's just the numerator, so don't do that. Use those parentheses for any fraction. For this one, we have 3/10 to the 4th power and x squared. You can just leave it like that, or you can put a little dot in the middle there. That doesn't matter to me. It doesn't matter. It's kind of inferred if there's a variable there that sandwiching them together like that is multiplication. To evaluate this expression, for number 3, you should have had 144. Okay. There are two 12s being multiplied together. For number 2, it is a positive, I'll tell you that. It is positive 64. And number 5 is a negative, guys. Number 5 is a negative. In fact, number 5 is negative 625. Right? Keep going. We have in negative 1 2/16. Okay, that is a fraction answer. That's okay. That happens. All right. Let's take a look at our next set of triads. It's just 3 problems working with those order of operations. Once again, pause the video, try them out, and then we'll go over them. Now that you've given them a shot, let's go ahead and go over them. That first one, you should have had negative 7. Negative 7. How did we do that? Well, first you go 5 to the 5th, and if you do that, you get 32. And 32 times 1/2 is 16. Okay, and 9 minus 16, that's negative 7. Right here, number 8. Right here for number 8, you get a 1 as your answer. 1. 3 to the 3rd power is not 9, it is 27. 27 divided by 27 is 1. And last but not least, it looks like we have inside those parentheses, we have 28 minus 64. Yes, 64, not 12. Please make sure you're doing those exponents properly. Okay? And that's going to be a negative 36 divided by 6, negative 6. All right. Thank you so much for joining me as we explored exponents and how to use them in order to write and evaluate expressions, and also how to write those products using those exponents. Until next time, this is Mrs. Stribble with Stribble Math. Have a good day.